Dear students, now we are going to look at depth first search and how to go about finding the articulation points. Alright, so let's do depth first search on this graph. We start with A. So that's the first vertex we pushed onto the stack, and then you visit, we have a lot of choices. You can go to either B, C, D or E. So you break the time by going with the vertex with the lowest alphabet. So you go to B. So that's the second vertex we pushed into the stack, and then between F and D you go to D. So that's the third vertex we pushed onto the stack, and then you go to F. Okay, so that is the fourth vertex. Actually, from D you can go to A too, but this is a back edge. Okay, because you have A already in the stack, right? So it's a back edge, and then you go to F. It's a tree edge, right? And because you visit F for the first time, so you push it onto the stack, and then you from F you could visit B, but again it's a back edge because you have B already in the stack. So you pop out F, that's the first vertex we popped out of the stack because you cannot go anywhere from F, and then you backtrack to D, and then you backtrack to B, which is the third vertex, and then you come back to A. From A now you can visit C, which is the fifth vertex to be in the stack, and then you go to G, and then you get back to go to E, and then you see this is a back edge. So when you pop out E, pop out G, and then you remove C from the stack, and then eventually remove A. Alright, so these are the tree edges and the back edges. So now what are the conditions for a node to be an articulation point? The root node of your depth first search tree is an articulation point if it has more than one child node connected to it through a tree edge. So it could be 2 child nodes or 3 child nodes or so on. It has to be at least more than one child node. Just having one child is not sufficient, more than one child, right? So that's the requirement for a root node to be an articulation point. Now for the leaf nodes, they are not articulation points. Now for an intermediate node to be an articulation point, they should have one or more subtrees rooted at a child. So at least for one child node, okay, so at least for one child node, so they may have one or more child nodes, right? Each intermediate node could have more than one child node, but for at least one child node, the subtree rooted at the child node, which could include that child node, should not go above the intermediate node and connect to a higher level vertex. Okay, so let's see some examples over here. So this is this depth first search tree that we have redrawn it here to make it more easy to visualize the same tree. So now you see A is an articulation point because it has 2 child nodes connected to a tree edge, this thing dark edges. Now F and E are not articulation points. Now if D has only one child node, and you see here this is a subtree rooted at this child node, and it's connected above D actually to B through this back edge, right? So what it means literally is, even if I remove D, F is going to be connected to the rest of the graph. So that's why we can say that D is not an articulation point. By articulation point, what we basically mean is, if you remove a vertex from a graph, the rest of the vertices get disconnected. If the removal of a node disconnects the other vertices in the graph, then we can say that node is an articulation point. Okay. Alright, so what about B? If you see here, this is one child node, and the subtree rooted at child node has a back edge that goes above B, so that's not an articulation point. Again, if you remove B, these two guys will be still connected to the rest of the vertices. Now in the same thing, G is not an articulation point because E is connected to A. Similarly, C is not an articulation point because this subtree is connected to A. So in this graph, only A is an articulation point. Okay. Now let's look at this. If you look at this, there's no back edge, so A is an articulation point, E and F are not articulation point, everything else will be an articulation point because there is no back edge connecting the child nodes of an intermediate node higher to any higher level node. Okay, so all these intermediate vertices B, D, C and G are articulation points. Now let's look at this. Okay, so you do a depth first search and get a depth first search tree that comes out to be like this. So A is an articulation point because you have two child nodes connected to a 3H. E and F are not articulation points. Now, is D an articulation point? No, because you have one child node only for D, and the subtree rooted at F, which is this one, is connected above D. Now, is B an articulation point? The answer is yes, because there's only one child node for B, and within that subtree you have this subtree, and you don't go above B, right, from this subtree. Alright, now E is not articulation point. G is not an articulation point because this subtree is connecting above A as only one child node. Similarly, C is not an articulation point because this goes above C. Okay, so A and B are the only articulation points in this graph. Now let's look at this. You can use this graph. Okay, so if you do a depth first search on this, you end up getting this. Okay, so A is the root. It's an articulation point because you have two child nodes connected to A, so more than one is sufficient. And what are the tree nodes for this graph? You have G is a tree, leaf nodes. So a leaf node is not an articulation point. Now D is a leaf node, so it's not an articulation point. Similarly, J is a leaf node, it's not an articulation point. Alright, so now let's look at F. From F, you have G is the only child, and G is connected above F to all these vertices, so F is not articulation point. Similarly, for E, this subtree rooted at F is connected above E, so it's not an articulation point. For C, again, you see now you have this subtree is connected to C only up to C, it's not connected above. But there's this subtree is connected above C, right? Because D is connected to A. So now we have to decide whether C is an articulation point or not. Again, the condition is this, and there should be at least one child node such that the subtree rooted at the child node doesn't go above this node. So in this case, this is what it is. There's one subtree rooted at the child node E that doesn't go above C. So that makes C to be an articulation point. Because if I remove C, these three vertices E, F and G will be disconnected from the rest of the vertices. Okay, so that makes C to be an articulation point. Okay, now B is not an articulation point because this subtree, which is the only subtree rooted at C, is going above B, right? So it's not an articulation point. B is not an articulation point. Now we decided J is not because it's a leaf node, K is not because this subtree is connected to H. You see, basically H is above K, so J is connected to H, so it's not an articulation point. So I is also not an articulation point because this subtree is basically connected above I to H. Now H is again not an articulation point because this subtree is connected to A, right, through this back edge. So it's only A and C that are the articulation points. Alright.